just kind of reiterate what we talked about yesterday. We talked about if-then statements, okay, formerly known as conditional statements. And they, like we said yesterday, are the structure of everything that we do algebraically, everything we do geometrically. So you guys deal with absolute value equations last year? Okay, so let me show you something that we can maybe look at that we have an experience with algebraically and see how the structure of those procedures are now being kind of discussed here in geometry. So if you guys remember back to Algebra 1, so if I had something like, let's say the absolute value of 2x plus 3 plus 4 equals 10. Do you guys remember how to solve that? You're going to subtract 4, and we get then the absolute value of 2x plus 3 equals 6, right? Now, do you guys know what absolute value, do you remember what that meant to us? Okay, so absolute value by definition is the distance something is from 0. And distance always has to be what kind of number? It always has to be positive, okay? Algebraically here, it gives us two solutions because if I'm looking at 0, let's say 0 is right here. Can you be a distance to the right of 0 of c units? So that would be some distance. Might be 10 units, might be 12 units, whatever. I'm just going to call it c. But could I also be over here and that still be c units? Yeah, so that's why in absolute value we get two solutions, okay? And what you went through last year was you would say, okay, well, 2x plus 3, you set it equal to 6. You wrote the word or. And then you just said 2x plus 3 again, and you set it equal to the opposite of 6. And this one here basically found us the answer to the right of 0, and this one here finds us the answer when we're to the left of 0. Does that make sense? Okay. Now, that rule, you were probably told isolate the absolute value and then create these two equations. But that rule is actually expressed across all of algebra this way. If we have the absolute value, now I'm going to write f of x in here, okay? So that is saying that that could be any expression. It could be any 2x plus 3. Does that make sense? 2x plus 3, 2x minus 3, 12x plus 5, could be anything, okay? If that is equal to c, then your f of x is equal to c, or f of x equals the opposite of c. Oops. F of x equals the opposite of c. And what we have to do then is we say, okay, does the thing that I'm providing, does my specific question, does this right here, that's what we started with, does that match to that right there? And they don't, right? Because the one on top has the absolute value bars all by itself, right? Does that make sense to everybody? So that's why initially we didn't rewrite the problem and say equals 10 and then rewrite the problem and say equals negative 10, okay? We had to move that 4 over first because we needed to get an expression or an equation that looked like that. Because now the two things that I have highlighted are the same. Does that make sense? Okay. So now the two things I have highlighted are the same. So then that allows me, when those two things are the same, that allows me to conclude this about my particular problem. And with my particular problem, this green stuff is that one right there and that one right there. Does that kind of make sense? Okay. So everything that we do in mathematics, the logic of why I go through a certain procedure or why I go through certain steps per the different math that we see is all because our rules are written as if-then statements. And I have to analyze what is in front of me. Okay, does that match up with some if statement, some if rule? And if it does, then I can make the conclusion about it. Does that make sense, everyone? Okay. Everything throughout all of mathematics, even, this was math you learned last year before we talked about what if-then statements were. So all the math that we've ever done is structured this way, okay? Now, here's the thing, and I'll show you something that I was working on with my other classes. You guys are probably familiar in a math class that we're going through a procedure, and they give you like 5 steps that you have to do, right? Well, these 5 steps right here for working with absolute value can all be taken away and replaced with this one phrase right there if we understand how to read, interpret, and apply that one phrase. Does that make sense? So that's what this section and a lot of this chapter is trying to get us to understand. Okay. Now, with if-then statements or conditionals, they can be just like random statements that have no, like they make no sense. Like I could say, if it is Tuesday, then dinosaurs are drinking Kool-Aid and playing dodgeball. Makes no sense, right? But was it structured as if and then? Okay. So what we want to do is determine whether these statements are true or false. Okay. If we can determine that they're true, that means there are no examples out there that would produce a false result. Okay. Which is hard to do. It's hard to show things that are to be true. It is easier to show things to be false because all you need is one example. We call it a counterexample that is going to show a conditional statement false. Okay. If we're going to try to show things true, we're either going to go off of like basic knowledge that we already know, okay, or like definitions or statements like postulates that they have guaranteed us to know to be true, or we'll go through what we call a proof kind of analysis of a statement and try to like link multiple things that we know true to build on top of one another to get to this final statement that we're trying to prove. And that'll be a good portion of this class is actually working through proofs and the logic that's incorporated in that. So we'll get to that eventually. When we call those things the truth value, whether if it's true, it's a truth value. If it's false, it's still a truth value. It's just true or false. We talked about that. Counterexample. Negation, I think, is where we stopped yesterday. Negation, it's just same way that you work with negation inside the English language. I put the word not in front of something to negate it. Okay. Now, when we negate things, it does not allow you to really make like pinpoint accuracy in regards to making a conclusion about something. For instance, let's say that let's say I was a student. Let's say Mr. Fay is not an A student. Do you automatically know what kind of student I am then? No, you cannot go to the direct opposite and say, well, he's an F student then. Because I could be a B, I could be a C, it could be a D, it could be an F, right? Okay. When the water is not hot, you don't want to say, oh, automatically it's got to be cold. Okay. Could be room temperature. There's varying degrees that it could be, right? Okay. So that's something to think about when we're talking about negating things. Okay. Says you use negations to write statements that are related to conditionals. Okay. The one thing I want to make sure that you understand that when we do this, when you insert the word not, because they're going to tell you negate the hypothesis, which is the if part, or negate the conclusion, which is the then part. You don't just put not haphazardly anywhere. You have to put it in there so that it like makes grammatical sense. Okay. So I would not say. So if I say the water is cold, I would not say not the water is cold or the not water is cold. Does that kind of make sense? I need the water is not cold. That's the most logical, grammatically correct place to put it. So just be aware of those things. But we use negations to write statements that are related to conditionals. It says each conditional has 3 other statements that attach to it. Okay, and we're going to be interested in their truth values. Okay, you ever been asked a question? And I see this on like ACTs all the time. Even in, of course, exam questions, like questions that ask you Like something like that. So let's say if an angle is not an acute angle, then it is not 50 degrees. Do you have trouble answering that question because of all the knots that are in there? Okay. So in everyday interactions, we have things like that. And you guys talk about like double negatives in English and that kind of thing. But if we are dealing with a situation that's hard to answer whether it's true or false, we might be able to, because it's an if-then statement, we might be able to rewrite it using one of these three related statements and be able to answer those as true or false easier. Does that make sense? And if I'm able to answer those as true or false easier, that will lead me, you'll see an example here, it will lead me to the true or false of the original much easier. Okay, so we'll see some examples of that here in a moment. But here are the three related statements. Now, these are all conditional statements. Okay, so a converse is a conditional, an inverse is a conditional, and a contrapositive is a conditional because they all start with if and they have then in them. Okay, but there are conditional statements that are directly related to an initial conditional statement that were provided, which we call the conditional. Okay, I know that gets kind of messy, but they're all if-then statements. But if I know which one is the initial conditional that I'm interested in, then the other ones are the converse, inverse, and contrapositive off it. Okay. All right. So the conditional statement we see here, it says how to write. It says usually given hypothesis and conclusion. Usually it's just given as an if-then statement, and you know that's my first one. That's my conditional. Okay. And we'll talk about the example here that they go through in a little bit and analyze that and all that kind of stuff. Okay. The converse is you take that original and all you do is you flip the if and then parts. Okay. You flip the if and then parts. You flip the hypothesis and conclusion. Okay. So let's write some just basic ones over here real quick. If I have my conditional statement, let's kind of come down here. Let's say my conditional, and I'll zoom in on this in a minute, is if it is October, then it is fall. Let's say that's my original condition. Okay. When we analyze this part here, the if part we said was our hypothesis, right? This part here is your conclusion. If you're going to write your converse, the converse takes those two highlighted statements and it flips their position. So I write if it is fall, then it is October. Does that kind of make sense to everybody? Okay. Now, here's the thing that we look at, because we're interested in the truth of these things. Would you guys agree the conditional is true? If it's October, then it's fall? Yeah, by our definition of seasons, October falls, we're in fall right now, okay? So that would be true. But the converse, which should have an E on it up there, if it is fall, then it is October. Can you find a counterexample to that? Yeah, it's September right now, correct? There's a counterexample, okay? November, there's another counterexample, right? So that doesn't necessarily, because this one was true, doesn't mean you can reverse it automatically and still get something that's true. And that's what we need to pay attention to in mathematics all the time, is because when our textbook gives us something as an if-then statement, they want you to use it the way they gave it to you, because reversing it's not possible. Because if it was reversible, they would give it to you both ways. Does that make sense? And a lot of people want to reverse things in mathematics, but you can't all the time. And there's special phrases that they use to tell you automatically that they're reversible. All right, so that's the converse. So yesterday we talked about some notation for conditional statements. If-then statements, we use the letters P and Q. So remember seeing P and then an arrow and then Q. And we read that if P, then Q, or P implies Q. This one here, because we remember P was the hypothesis and Q was the conclusion. Here, we flip those, and it says if Q, then P. Okay, so that's what a converse does. I think converse is the easiest of the ones to create. Okay, the next one is the inverse. And you see here it says the inverse, you negate, so this is, we're going to go back up to the original. You go back up to the October. If it is October, then it is fall, that original. So you negate both the hypothesis and the conclusion of the conditional. Okay? And it might even make sense in your notes to write of the original conditional. Okay? So we negate both. So that means we're going to put the word not in both statements. Okay? So, going over to our specific question over here that we're working on. So the inverse says you're going to start back up here with the original, and you write, if it is not October, October, spelled right, then it is not fall. Okay. Now, obviously, you would not usually, when you're writing these, capitalize not. Just trying to make the emphasis here that we're negating both parts there of the original. And now we ask ourselves, okay, if that's true or false. Okay. Well, if it's not October, then that means it could be January, February, March, April, May, June, July, August, September, November, or December, right? Because you want one of those 11 options if it's not October. Are those 11 options all not fall? No. There's some of those are September and November, right? Which are fall. So this would be still a false statement. I think that's what I start off with at the beginning of the class, and I said, have you ever answered, or not the beginning of class, but the beginning of this discussion, that questions like that, if it is not October, then it's not fall. I struggle thinking logically about answering that, yes or no. Okay? So if I was presented with that question initially, I would do a little bit of what we're doing right now with it to answer it yes or no, or true or false. And we'll come up with an example here in a moment that kind of validates that idea. So this is still P and Q. That's the order. Okay, October came first, right? Fall came second. But now because I put the word not in front, the way we identify that with these symbols is that we put this little tilde out in front. Okay? So we say not P, then not Q, or not P implies not Q. We won't do an immense amount of work with those P implies Q, like symbols. Okay, there are a couple questions in your homework. There might be one or two questions on a quiz or test using those. But there's something called truth tables that used to be a pretty important part of geometry per the state. But you guys lucked out, and the state, when they redid their standards, said truth tables were not something we need to spend a whole lot of time on, so we don't. So truth tables would use those symbols a lot. Okay. The last one is called a contrapositive. Okay. Contrapositive. A contrapositive is basically the merging of the converse and the inverse together at once. So the converse flips things, right? So in the contrapositive, you're going to go back to the original and you're going to flip things. The inverse negated things. So once you flip them, you are then going to negate both of them. Does that make sense? Okay. So sometimes people will define the contrapositive. They will say it is the inverse of the converse. It's the negation, essentially, of the flipping. Okay, the negation of the converse. Sometimes they'll say it's the converse of the inverse. They'll take the negation and they'll flip it. Okay. But basically, to create the contrapositive, you start with the original conditional statement, and then and these steps are independent, so it doesn't matter the order that you do it. You negate both sides, and then you flip it. Okay? So that's effectively constructing the inverse and converse together at once inside the statement. So over here, we do our contrapositive. We're going to flip them. Okay? So I'm going to just write if it is fall, then it is October. Okay? So when I flip them, that just created the converse, right? Now I need to negate both these. And now it's a contrapositive. Does that make sense to everybody? Or I could have written it this way. I could have said, well, I'm going to start with this this one here and say, if it is not October, then it is not fall. And that's just creating the inverse, right? Now, once I take this one here, let's cut it, put it there, take this one, cut it, put it there, clean it up a little bit. Is it still the same statement? If it is not fall, then it is not October. If it is not fall, it is not October, right? So you can either negate them first and then flip them, or flip them and then negate both of them, okay? But regardless, you get that statement. If it is not fall, then it is not October, okay? Again, that statement I struggle with, okay? If I'm thinking about the truth value, I don't always have success in determining that, okay? If we're using the symbols say you flipped it, so Q comes first, P comes second, and you negated them, so you need to have that tilde out in front of both of them, okay? Now, let's say that you struggle answering these as true or false, okay? So let's say Mr. Fay told you, we're going to start with, doesn't matter, let's go with this one. So I asked you that question on a test, true or false, okay? And on a test, guys, these questions are probably going to be more math related, and you have trouble answering it true or false right away, okay? Oh, spelled the wrong thing, conditional. So this is I'm going to say this is my original conditional I'm asking about, and I don't know true or false. So what I can do then is I can write the converse of this. So converse says if it is not fall, then it is not October. Okay, that might be easier for me to answer, right? If it's not fall, then it's not October. I understand that one a little bit better. Okay, I could do the inverse. Remember, inverse of the original is if it is, okay, now not is already there. What do I get when I negate a not? I write not October, right? Well, what's not mean? It is, okay? So if it is October, then it is fall. That might be much easier to answer, right? And then the contrapositive would be negating the first one, negating the conditional, and flipping it. So I'm going to write if it is fall, then it is October. Okay? Now, those four statements individually right now, I still have to be able to answer whether each one is true or false. But there is a logical rule that's going to allow me to do this. So let's go talk about that rule, and then we'll come back here and answer these questions as true or false. The logical rule says this right here. Get to it. It says when you find two statements that have the same truth value, meaning they're both true or they're both false, we say that they are logically equivalent. Okay? So logically equivalent. Equivalent means the same, right? The logic part just refers to the true or false. Okay? So is the true part the same or is the false part the same? And then we have this principle of all conditional statements, all if-then statements. If you have a conditional statement and a contrapositive, if you're able to construct those, they are always 100% of the time the same truth value. They are both always logically equivalent. So if I have a conditional that is true, then I automatically know without even reading my contrapositive that whatever my contrapositive turns into, it is also true. Does that make sense? Okay. The converse and the inverse, they are always logically equivalent. They are always both true or they're both false. Okay. The way I remember which ones pair up is the one that have verses in them. Okay. That word, they pair up, and then it leaves the other two to pair up as well. Okay. So let's go back to our question, or our conditional statement that we had created. And like I said, I struggle with this first one as being true or false. But if I know that my conditional and my contrapositive should match, can you answer this one? If it is fall, then it is October. Is that true or false? Can you find a counterexample there? That's false, right? We have counterexamples September, November. This is false. So what does that tell me about the conditional? Automatically false. And now I know for certain that there is a counterexample for that original conditional. And it's going to be the same counterexample that we were able to use in our contrapositive. Okay? Now, if I look at my converse and my inverse, I want to tell if they're true or false. If it is not false, I never look at the one that has not in it. I struggle with those a lot. And if you don't struggle with them, you don't have to worry about that. Okay? But I struggle with them, so I'm going to look at this one. If it is October, then it's fall. True or false? True. So then I automatically know that if it's not fall, then it's not October, which is one that we could probably all agree and answer true. But like I said, when we put math context into some of these, they're hard to answer. But if I know that the conditional and contrapositive always have the same truth value, the inverse and the converse always have the same truth value, and they start me off with this, and I can't answer, or I'm uncertain about it, write the contrapositive and see if you can answer that as true or false. And it'll tell you what the conditional is. Does that make sense? When we talk about these things, we always want to talk about them, at least in your homework, just to get practice in groups of 4. You can all, when talking about truth values, you can only have all of them true, all 4 true, or all 4 false, or 2 true and 2 false because of how they pair. Okay, you can never have 3 false and 1 true. Doesn't work that way. Okay, so let's talk about the examples here that they gave to us in there's more math context here. Okay, it says if measure of angle A is equal to 15 degrees, then angle A is acute. Would you guys agree that that's true? By definition, that should be true. Okay. The second one says the converse says if angle A is acute, then measure of angle A equals 15. Okay, so what is that saying? If you have remember what the if part means. The if part means if you had this picture in front of you, you had this angle in your hands, and you knew that angle A was acute. Does it allow you then to say that you know that angle A is 15 degrees? Would you know that, or are there counterexamples? If I give you an angle and say, hey, that angle, or close your eyes, there's an angle in front of you, it's acute. Do you automatically know it's 15 degrees? No. There's counterexamples, right? Okay. So it could be 20 degrees, could be 30 degrees, could be anything from 0 to 90, right? Excluding those 2 values. So there are counterexamples of this. This would be false. Okay. Now if I look at the next one, okay, the inverse. Okay, so go back to the original conditional, and all I did is they negated. Now, when I say negation, and I'm using equality here, so this says if measure of angle A is 15, that's the original conditional. If I say if measure of angle A is not 15, well, is not means not equal to, right? So we put that equal sign with a slash, that's negating equality, okay? If I had like a greater than sign, what is the negation of greater than? Less than or equal to, okay? So here we've got if measure of angle A does not equal 15 degrees, then angle A is not acute. So if I told you, close your eyes, and I put an angle in front of you, and I tell you that angle is not 15 degrees, can you automatically tell me it's not an acute angle? No. If it's not 15 degrees, it could be 16, right? And if it's 16, it's still acute, which they're saying it had to be not acute, okay? So there's a counterexample to this. Now, if your goal was just to determine whether it was false or true, you already knew the converse was false, right? And the converse and the inverse are always logically equivalent, right? That last one, okay? Let's not even read it. Is it true or false? It's the contrapositive. Is it true or false? It's true. Didn't even read it. Why is it true? Because the conditional is true, okay? But if I say if angle A is not acute, so close your eyes, angle in front of you, not acute, then measure of angle A cannot be 15. Well, if it's not acute, then it either has to be right or obtuse, right? So 90 or bigger. So then it can't be 15, right? Does that make sense? So that has to be, there's no counterexamples that we can create there. That has to be a true statement. Okay? So, if on a test, we're looking at, I wrote in the last test maybe some postulates. I reorganized the way we thought about them. I took some words out, took some some phrases out, and asked you, are they true or false, always, sometimes, never type thing. If I give you more questions like that, maybe on a test I give you that contrapositive down there at the bottom. It says if angle A is not acute, then measure of angle A does not equal 15. If that's the conditional that we start with, okay, I give you this on a test, and I ask you, is that true or false? And you struggle with it, could you write its contrapositive, which in this case, if I flip that and negate it, it's going to create this. Could you answer that top blue one as true? And you automatically then know the one that I'm actually asking you about is also true. Okay? And all of our if-then statements in mathematics and just life in general are that way. Okay? Always logically equivalent like this. All right, so these are just some practice. Let's get down here to some math ones. All right, so I'm going to start you with an original conditional that says, if angle 1 is not congruent to angle 2, then angle 1 and angle 2 are not vertical. Okay, we've talked about vertical angles, right? Okay, if you remember vertical angles, they are, I should probably write this on the screen. Vertical angles are two angles in which they are created by intersecting lines, right? So if I look at like that line and that line intersecting, this angle right there and that angle right there are vertical, correct? Okay. And likewise, the angle that's here and the angle that's there are also vertical. Okay. What does it look like vertical angles are in regards to their measurements? The same. Okay. Now that's a theorem that we haven't gotten to yet, but right now I'm going to tell you vertical angles are always congruent. Okay. They are essentially mirror images of one another. Okay. So if I'm looking at this and I want to determine the truth value of these, okay, if angle 1 is not congruent to angle 2, then angle 1 and angle 2 are not vertical. I struggle with that. I don't know if that's true or false. Let's come up with these other statements and see if we can help us decide this true or false. Okay, so the converse. Okay, I'm going to highlight my hypothesis and I'll highlight my conclusion. And when I write my converse, I'm just flipping the yellow and the green, right? Okay, so I'll do that. converse says if angle 1 and angle 2 are not vertical, then angle 1 is not congruent to angle 2. Okay? Still struggling answering that. Not certain. Okay? So let's write the inverse. Remember, we're always coming back up to the original. So let's write the inverse of that. What's the inverse? What do I include in the inverse? The negation, right? I include the word not. So I'm going to put a not here, and I'll put a not in here. And there's already nots there, so they basically wipe each other out, right? So negating a not, two wrongs make a right, right? Is that true? Two wrongs make a right? No, that's wrong, correct? But two nots make in English, you don't write a double negative because there's a better way of writing it, right? So if angle 1 is congruent to angle 2, then angle 1 and angle 2 are vertical. Okay? I have a better understanding of that right now. If I look at it, I can answer this one as true or false now. If angle 1 is congruent to angle 2, then angle 1 and angle 2 are vertical. What is that saying? If I tell you, close your eyes, you got two angles in front of you, they're congruent. Do you automatically know they're vertical? Do you automatically know their orientation? No. Okay? They could be, I could give you two angles like that. I could say this angle here is 30 degrees and this angle here is 30 degrees. They are not vertical. They're not sharing a midpoint or not a vertex. Okay? They're not sharing that point. Their sides aren't opposite rays. Okay? But they're congruent because they're the same angle, the same shape, and the same size, right? So that would be a counterexample to this. So I can now say that the inverse is false. And if the inverse is false, what's the converse? Converse is false. Okay? Now, I still haven't been able to answer my original conditional, but I'm getting there. Okay? Remember, the original conditional is to take and flip and negate. So what I'm going to do, I'm just going to cheat a little bit here and cut and paste. Well, that didn't work very well. Never mind. Let's go if. So I'm going to take the converse and negate it. So if angle 1 and angle 2 are vertical, then angle 1 is congruent to angle 2. Okay? So I was taking the original, we flipped it to the converse, and then we negated both those, the hypothesis and conclusion, and it creates my contrapositive. So if you know two angles are vertical, tell you close your eyes, two angles in front of you are vertical, can you tell me that they're automatically congruent? Yes. So that statement is true. So if that statement's true, what's my original conditional going to be? It's true as well. Okay? Now initially you guys might think, man, that's a lot of work to answer true or false for one statement, right? Traditionally, if somebody gives me a conditional statement and I'm not certain about it, I'm going to go straight to the contrapositive, which I know because of my experience with converses and inverses of how to create that almost instantaneously. Does that make sense? And I can answer that. So if it has not in it, I'm going to automatically go to the contrapositive and try to decide true or false. Okay? And that will lead me then to my argument by the conditional. Does this make sense? Is something we can do? Okay. Now, I know it's something because I've taught this for 13, 14 years. It's something that we think right now, yeah, this makes perfect sense. This is a breeze. This is easy. We will always come back to everything that we talk about through the entire year is going to be based off of this understanding of what conditional statements are and how we interpret them and how we read them. Okay. So it's not something that you can say, I got the hang of it, I'm going to be successful in test and quiz, but then after the test and quiz, I'm just going to throw it out the window and forget about it because it's always going to rear its head and be a component to new material. Okay, so just keep that in mind as we move forward. I'm going to open up 2-2. It's not something that's the one thing about the homework in this section, in this chapter. They're not things that should take you an excessive amount of time, but I want to make sure that you do understand the concepts. Okay, so open that up. That'll be due, let's say Tuesday, be due Thursday.